Well, let's get started. So, welcome everybody. This is Platform Engineering Zero to Scale. My name is Josh. So, a little bit about me. My role is I am a solutions architect here at Pulumi. But I have a lot of prior experience in the field prior to joining Pulumi. So, for a brief time, I was a site reliability engineer at an organization called Oscar Health. Before that, I spent about 4 years as a cloud consultant for a company called Second Watch, which has since changed the name to Allianz. So in that role, I worked with a lot of Fortune 500 companies. I worked with a lot of startups. I did all sorts of engagements with them, everything from like cloud migrations through like sort of DevOps consulting and like doing analysis of their practices and suggesting how they might be improved. I did a ton of work around infrastructure as code. I've worked with kind of all the major compute platforms, virtual machines, containers, serverless. So I got a very, very wide range of experience with a wide range of organizations in that cloud consultant role. And that sort of field knowledge is going to inform a lot of what I'm presenting to you today. Prior to that, I was also a DevOps engineer at an organization called eMoney Advisor. They are a Philadelphia-based SaaS corporation, and they make software for financial advisors. So I'm also familiar with the regulatory landscape that exists out there. And I live in Philadelphia, PA. I am a native Philadelphian. I was born here, and I've lived all my life here. So that's a little bit about me. But let's talk about platform engineering. So first and foremost, how does the need for a platform and a platform team arise within an organization? So this example I'm showing here is largely enterprise oriented. So typically the way that cloud adoption happens within an enterprise is you have one team in one part of the org, and they want to run their next workload in the cloud for whatever reason. They may want to take advantage of a managed service. Or they may want to, it could be any number of reasons, right? But so this one team is going to start, and they're going to maybe start running their application, their first application in AWS, and they're not necessarily, coordinating with the rest of the organization. And you're going to have another team somewhere else that might want to say, okay, we want to run our workload in AWS, but we want to do our data warehouse in Google Cloud, for example. And then you have another team that says, okay, well, we are running a .NET workload. We know Microsoft really well, so we're going to run in Azure. And what you have is kind of have these uncoordinated application teams. They start running their workloads in the cloud, and there isn't a lot of coordination between these parts of the org. They're kind of all doing things in a different way. They might be using different compute platforms. They might be using different database platforms, different clouds, different services within those clouds. They may care to varying degrees about they may have different regulatory requirements. They may be, some of them may be outsourced to contractors or consulting orgs, and some of them, they may have varying degrees of like knowledge or care about things like security. So, application teams have their own sets of motivations and what they are incentivized for. And they are generally incentivized and care about things like the functionality of the app and knowing the domain of whatever it is that the application is doing. For example, if you're in the airline industry, like the application team should know something. For example, if they're making like a baggage tracking app or an application for terminals when they load the plane, like they need to know about those business processes, right? Those are functional requirements. They need to, and they are motivated to ship their software to production so that the business can grow, or can align with whatever the business goals are that's associated with the code they're running, right? Because you only run code in an enterprise environment, really, most anywhere. You're running code in a business environment so that you can accomplish some sort of goal, right? So, but they are not especially incentivized to think about these sort of global things or these sort of longer term things that traditionally might fall upon the operations side of the organization. So this is like kind of like your classic dev and ops, divide that you saw, which spurred the DevOps movement. And some of those things the application teams don't care about as much are going to be like their delivery pipelines. They're really only going to care that they work. Or at least that they can get something into the production environment. It doesn't really necessarily matter that much how much it's automated unless that stuff comes back to the development team. They don't typically have a ton of expertise in infrastructure, whether that's on-prem or in the cloud. They don't. They're not going to have a ton of expertise in operational concerns, things like logging, metrics, observability, that sort of thing. They are rarely concerned with cost controls. Again, that's not something that the bill is typically not coming back directly to the application team. They may have varying levels that they care about security and compliance, but in my experience, those things typically have to be imposed upon development teams from an outside source. Very rarely does a development team take on some sort of security initiative on their own without being instructed to by some part of the security organization. And then finally, of course, because governance and standardization are global concerns for like the org. So like if you're an individual app team, it doesn't really matter to you whether you're using Postgres and everyone else is using MySQL. All you care about is like what actually works for your app. So governance and standardization is not something that is typically going to be something that is on the radar of things that an application development team cares about. So what you see in many organizations is this new-ish pattern called platform engineering. And in a platform engineering, you have a centralized platform team. If your organization is very, very large, you may have several platform teams, but there's at least one platform team. Each platform team is going to create this thing called the platform. And the essential nature of the platform is kind of the standardized way that you get an application into some sort of production environment and operate it there. And so like when you have this pattern, this organizational pattern of a platform team, it gives and this product of the platform, it's going to give these teams like one place to go so that they don't have to figure out all this stuff themselves. And then it also gives a huge advantage, which is that the security and compliance org only needs to interface with the platform team. They don't have to go out and validate every single application before it goes to production. All right. So what is a platform? Let's dive a little bit deeper about what it is. So it's kind of hard at least for me, to summarize in some sort of neat single quote. But the way we can kind of break this down is we can talk about its characteristics and its contents. And it's going to be different for every company, right? There is no such thing as a single one-size-fits-all platform in a box that meets the needs of every organization. The cloud landscape is too complex. You can't. It's virtually impossible to abstract away the differences between the clouds. The closest that we have is Kubernetes, and Kubernetes itself is not necessarily a fit for every organization. In fact, I would be so bold as to say that probably the majority of organizations that are running Kubernetes probably don't need it. But there also are organizations that very much do need it because they are at a sufficient level of scale and complexity. But I digress. So, let's talk about these platform characteristics. So the first, it's a standard way, again, as I said earlier, to deploy and run applications. And there doesn't necessarily just have to be one way, right? You might have multiple clouds, you might have multiple compute platforms, right? So, running on a virtual machine is obviously going to involve different things, especially if you're doing like mutable infrastructure, right? So if you're deploying in an automated fashion to the same virtual machine over and over and over again, that's going to involve some different mechanics, for example, than deploying a container to a containerization service, or let's say if you're doing serverless, deploying an entire serverless application. So there might be multiple ways to deploy these applications. And there's also going to be standard ways to run these applications. There's probably more convergence on a limited number of ways. But when we talk about ways to run applications, it's, what are your supported compute platforms? What are your supported clouds? What type of observability tools do you have in place? Logs, metrics, SLOs, things like that. Those kinds of tooling might even include things like on-call rotations and your alerting systems. There's probably going to be a lot more convergence there, right? Because you probably do not want, let's say, two different like alerting vendors, in the same organization. That's probably not going to be what you're looking for. It obviously has to abstract away some details, right? If you are passing all the complexity right back up to your application teams, then you are adding absolutely zero value to the stream. So you certainly want to make sure that you're abstracting something useful away from the from the application teams and taking that on yourself as a platform team. And then I think the most important characteristic of what a platform is, it is an internal service whose customers are application teams. It might actually even be a series of services that you provide. But essentially, it's a service, or you can think of it as a product, and that the platform teams are the owners of that, and that their customers are the application teams. And I'll talk a little bit later about the importance of a sort of customer mindset when you're operating as a platform team. Some of the contents. So you can break these down broadly into two different categories. You have your pre-production stuff and your post-production stuff. Everyone who's running code, virtually, hopefully at this point, is using things like version control. You're going to have some sort of continuous integration. You're going to be producing some sort of artifact for the code that you write, whether that's a jar package if you're running in Java, or maybe a container. Some sort of deployable artifact is going to be the result of your continuous integration build. You're probably going to have some sort of static analysis. This is less ubiquitous static analysis, but I think a lot of companies are at least doing something like using Sneak to scan for vulnerabilities, or dependencies that may have vulnerabilities. And then you're also going to have some sort of application delivery that can be continuous deployment if you are doing it in automated fashion, but some sort of automated delivery. And the rest of the pre-production stuff we're going to get into a little bit later. And you have your post-production stuff. So the stuff on the left, those are essentially the things that happen before you deploy to production, right? And then on the right, you have your post-production stuff. So that's all the things that you need that are much more operational centered. So things like secrets management, foundational infrastructure, runtime platforms. So like, governance, setting up, for example, the Kubernetes cluster, if you're running Kubernetes, that your application is going to run on, monitoring observability, detected controls. I forgot to add databases there. That's another thing. So like backups, recovery. It's actually a few things I could add to this. Yeah, backups and recovery, things like disaster recovery, resilience, all of those things are sort of post-production. Dynamic scaling is another way to get cost controls in there. There's a lot of post-production stuff that I'm probably going to add to this slide before the next time I give this talk. I see we have a good question here. So let's take a look here. All right. In your experience with other orgs, would the platform team also deploy and operate the platform in production in order with PCI and SOX compliance, which mandates that the operations team operates the production platform? That's a great question. So I have a good general feel for regulatory environments. I would not say that I necessarily have deep expertise, but my intuition has generally been proven right. So my understanding with PCI and SOX is it talks about segregation. Basically all of these regulations involve usually a chain of custody, right? So there has to be some sort of process, and how that process is actually implemented. It has some hard requirements, but it also has some soft requirements where you're it's kind of like, okay, you can write your own process as long as it fulfills these general requirements, and you have to be able to prove that you followed it. And if you didn't follow it, you have to say why. So I think that is a generally evergreen, an evergreen description of pretty much any regulatory requirements. They all have that kind of feature in common. So with PCI and SOX, in no way do you ever have to say, okay, you build it, you run it. The platform team may or may not be the SRE team. You may have, and there's a lot of different organizational patterns. And Diana, if you could find the team topologies website, there is this, there's all these diagrams that basically show you all the ways that you can kind of do DevOps. And included in that is platform engineering. And so they show you all these like Venn diagrams where it's like who's responsible for what and what the 2 or 3 teams might be. So Um, Sometimes the platform team is grouped in complete with operations. I would make the argument that a platform team is much more operations than development. And you might Charity Majors, for example, I heard her say that that platform engineering is essentially modern day operations. So yes, so sometimes the operation team, um, the platform itself the parts of the platform itself are kind of to me like neither really production nor development. They're kind of like their own thing. And even when I've like done this and modeled this in like AWS accounts, like the actual platform stuff goes in its own account. It's not it has a pathway to the production account, but it doesn't actually live in the production account. So if you want to think of environments as AWS accounts, for example, it's kind of neither production nor like not production. It is a production service, right? Because if it goes down, then if the platform is unavailable, then no one's going to be able to deliver anything new to production, which would prevent you from, for example, resolving most production incidents. This is quite a rambling answer. I hope you're getting something from this. Gavin, if you could give me a little feedback in chat if this is actually answering your question, and if not, we can re-ask it, and maybe I can drill it down a little bit. But this is a great question. So yes, sometimes the operations team is the same as the platform team. Sometimes it's separate, but the overall skill set is, I believe, more operations centric than it is developer centric. But you also need developer skills. All right. So hopefully that that got to some useful information. But it was a great question. Okay. So just another note that platform engineering does not necessarily require strictly like self-service infrastructure, where in the form of a service catalog. By the way, if you don't know what a service catalog is, like ServiceNow can be a service catalog. So it basically means like an application team goes in, they pick some number of components, they're filling out something probably in a web UI. You can also do this in a command line if you want, and they're filling out, they're like, I want let's say a Go containerized app, and I want Postgres as my backend database, and you click and you fill the stuff out, and then you click run, and it deploys everything, and then the application teams take it from there. That is a very, very high level of performance if it is done well, by the way. I've also seen it done poorly, and we're actually going to go into some scenarios that talk about poorly implemented platforms and what to do about them later on in this talk. But you do not necessarily need to be doing self-service in order to say that you are doing proper and appropriate and well done platform engineering. Also, it does not necessarily require Kubernetes. Some organizations who may have a commercial interest in doing so tend to conflate the idea of like internal developer platform with like, oh, it has to be Kubernetes. Don't believe the hype. That is not true. You can absolutely do great work platform engineering, deploying on mutable infrastructure onto virtual machines, if that's what's appropriate for your org. So don't feel that you need to adopt certain compute platforms in order to do the platform engineering work that your organization actually needs. All right, I'm going to take a little sip of water here. Okay, so the next thing I want to talk about are some milestones that are on the course to developing a mature platform. These things I do present them as step 1, step 2, step 3, but really they're kind of like processes that you start in a certain order, but each process is ongoing. And so it's not like you start step 1 and then you get step 1 to some sort of finished place. These are things that you need to come back to and make sure that you're in alignment kind of with the strategy here. So the first thing to do is to get executive buy-in. The level of leadership at which you need to get buy-in will vary from organization to organization. But because fundamentally, right, if we go way back in the slides, right, you have, and the number of teams in this slide is 3, but in reality, you might be dealing with 6, 10, 20, could be any number of teams depending on the size of your org. And what you're fundamentally trying to do is rein in the chaos, right? You're trying to create some sort of top-down organization and guidelines that and guardrails right, that are going to rein in this chaos, right? So in order to do this, if we harken back earlier to what we talked about, so you're trying to make an application team change what they're doing for something that they are not necessarily incentivized to care about as a team. The organization as a whole is incentivized to care about this, and that's why you're doing it. But in order for this to be successful, you have to get buy-in from someone who's high enough in the org chart in order to make this effort successful. So that's what I'm talking about when I say get executive buy-in. You're going to have to pitch upward unless you are that IT leader, right? If you're the IT leader, you can just say, hey, this is what we're doing. But if you're not the IT leadership that is high enough on the org chart to make this happen, then you're going to need to get buy-in. And so you're going to have to pitch creating the team. And when you make this pitch, you're going to have to talk about for sure some measurable outcomes that align with these business goals. And so that might be things like the DORA metrics, which are off the top of my head, deployment frequency, lead time, mean time between failure, and change failure rate. And Diana, if you could grab a link to the DORA metrics, I think Google Cloud has a really good source on this, and throw that in the either in the chat or in the handouts, that would be great. But those are like some examples of metrics that are basically kind of overall health metrics, right? And so, if you want, generally speaking, when you talk to leadership, right, you're going to need some combination of inspirational ideas, but then also measurable outcomes, not just squishy stuff. You're asking for some amount of the organization's resources, which are of course limited. So you're asking for headcount. You're going to be asking for budget, for tools, and so like again, you're going to need to get buy-in from the top level, or from whatever level is high enough on the org chart that it can influence the folks who you're going to be at least at first inconveniencing as you make this platform engineering effort. So the next thing after you've gotten that leadership buy-in, you're going to have to staff the team. The most important thing on this slide is the customer focus, right? So, you need to treat your application teams as customers. Yes, there is a certain amount of if we talk about carrot versus stick, right? There's a certain amount of stick involved. Like, hey, like you got to stop, doing these wide open network ports, for example, like because you're going to have to clamp down in terms of security. But then you're also, in the long run, you're going to make these application teams' lives easier. You're going to be making it easier for them to deliver. But in order to do that, you need to make sure that you have empathy for their concerns, and that you that you take those concerns and make sure that those are present in your team's product, which of course is the platform. And then you're going to be interfacing probably with the security org as well. So make sure that you work with them in an empathetic way as well. Because, their jobs can be really hard. And like, when something goes wrong, it's often the security team that could be getting blamed. So, make sure that you are empathetic to the difficulties of their job as well. Another feature of successful platform engineering teams, they tend to be very good at glue work, right? So if we go back to this diagram earlier, and this is the first time I've been flipping slides, so I'm going to do this direct next time. So if you look at this, right? So we talk about glue work, right? Glue work is the hub in the hub and spoke kind of architecture that we're showing here. This is like an organizational chart, right? The platform team sits in the middle of all the application teams, and you may even have the SREs as a sort of downstream consumers of the platform. And so, you need to be good at bringing teams together, at assimilating, at talking to the people that are using the work you're doing, understanding their concerns, and designing a product that meets their requirements. You have to be able to manage up, right? So like you may have some sort of director of application development who might not be happy with your efforts to impose order. And then you're going to be able to need to work with those people as well, right? Because you're probably going to be working with different parts of leadership across the IT org. Of course, you need some sort of infrastructure expertise. You do not, by the way, one of the things the platform I failed to mention, Platform engineering, by the way, does not have to happen on the cloud. You can be doing platform engineering just as well on-prem as you can in the cloud. But you're going to need some sort of infrastructure expertise for whatever infrastructure you're provisioning. So that might involve, databases, that might involve networking, compute, storage, the usual components of infrastructure. And you're going to need to understand those for whatever platforms you're dealing with. If you are creating Kubernetes clusters, then obviously you're going to need to understand how Kubernetes operates, how to ensure that that you don't lose data, things like that. You're going to need to have some sort of understanding of where the money goes in the org, and how to track where the money goes, and how to attribute costs with whatever your organization's system is. So that's what I'm talking about when I'm talking about FinOps. And then you're also going to need a certain amount of development expertise in the team. By the way, this does not all have to be, not all these attributes have to be present in every member of the team, right? Some people are going to be good at one thing, some people are going to be good at others. But as a whole, you're going to need to have a sufficient amount of expertise in all these different areas. So when it comes to development expertise, right, something you're going to be producing is likely going to require versioning, or is going, you're going to be necessarily abstracting something from the application team. So you're going to have to know how to create stable and useful abstractions. And that's what I'm talking about when I say development expertise. Next, you're going to need to define the platform mandate. So this is something that I encourage in general, no matter what team you work on. You should probably have some sort of page. You might do this in a Google Doc. You might do this in your company's information management system. So if you're using like Confluence, for example, you might want to make a team homepage in your Confluence structure. And some of the stuff that you want to start in there. And I really love writing this type of thing down and being explicit about it. Like, why does this team exist? What are we doing? Like, what are the organizational outcomes that we are trying to create? What are the systems that we're responsible for? How are we supporting those systems? You can even go, if it's scalable at your organization's size, you can also say, like, who are the team members and like, what are their areas of expertise? In some platform engineering models, you might also do what's called the envoy model. And so in the envoy model, each team member is the primary point of contact for some number of application teams. So, platform team member 1 is responsible for app teams A, B, and C. Platform team member 2 is the primary contact for D, E, and F, something like that. By the way, I found that to be a very, very effective way of operating, especially when you're just getting started, as long as your application scale isn't like so ginormous that you wouldn't be able to scale this. But like in most orgs, certainly in anything up to a couple thousand employees, you should be able to have this sort of envoy model where each platform team member is the primary point of contact for some number of application teams. And when you write this down, you get this ironed out enough to share it, you should make it public. It should be publicly viewable. I actually took a crack at I asked Claude, which is an AI model by Anthropic. I'm not endorsing that. It's just what I happen to use. I asked it to create that document, and this is actually what it came out with. And it's pretty good. This is basically what it would look like. So, you start with an introductory paragraph of what your responsibilities are and what your goals are, and then a list of the systems they support. How do you get support, and then who are the people on the team, and what are their roles within the team? So, this will help. That our team part will help with helping applications team find the right person for whatever it is they need to know. So, if you have someone who has deep expertise in databases, that's good to list, because that's who the application team should reach out to if they're having some sort of if they need some advice on structuring their indexes or something like that. So this is good stuff. So good job to our AI overlords. So once you define the team's mandate, it's time to start actually producing some work. And I often find that the first place to focus on, or so the early pre-production pipeline. These are services that are typically used by just your development teams, and it kind of doesn't really matter where you're operating at this point. You might be in the cloud, you might not. You might, you could be operating on any platform. You're still going to need things like version control. You're going to need some sort of continuous integration and testing. You're going to need some place to put your artifacts. You're going to need typically you're going to need some sort of static analysis. So that would be something like Sneak or, there's any number of vendors out there that do static analysis, but essentially it's going to verify that your application code itself does not have vulnerabilities, and also that the packages that you are incorporating don't have critical vulnerabilities or aren't otherwise unsuitable for the organization. For example, if they might have a license that isn't compatible with your organization's use case. And this is exactly what I did at eMoney Advisor. These are the systems that my teams were primarily responsible for. We were operating on-prem, and really, if this is all your organization needs, and you're not ready to move to infrastructure as code, and this is a really, really great start. And this may be the eventual end state. So, these are the kind of the starting services. Now, most organizations, I'm guessing most folks in the audience are probably going to progress beyond this. And so kind of the next thing that comes in is infrastructure as code. And you'll notice that, we went from 5 things being in bold to, well, a lot of things. Everything, pretty much everything on this is now enabled by infrastructure as code. However, it is definitely useful if your infrastructure as code tool if you have a single infrastructure as code tool that will allow you to manage all of these different things. And not every infrastructure as code tool can do that. So you definitely want to look at something that allows you to manage all these things with a single tool, and also to orchestrate them all within a single program. That is a very, very useful thing to have in infrastructure as code. So obviously, your IAC is going to be able to manage foundational infrastructure, your networks, things like that. You can use it to create dashboards in your monitoring and observability tools. You can use it to define your log stores. You can use it to define your SLOs and your alerting that comes off of that. Obviously, you're going to use it to spin up your runtime platforms, for example, Kubernetes cluster, or other clusters that you might be running on. You can use it to manage your own secrets. You can certainly use it to create pipelines in most tools. I would definitely recommend that you do that. In fact, it's a very efficient way, because you're going to need a lot of pipelines, and so having that standardization that comes from defining those pipelines as code is super helpful. And again, I do think that a single tool to manage all of these things is the way to go. Okay, so infrastructure as code is obviously going to enable quite a lot. And you can also, by the way, use infrastructure as code to manage those other things, right? So, for example, in Pulumi, we have providers for GitHub and GitLab, so you can manage, you can create repositories and manage their lifecycle with them. You can manage their permissions with them. That is another thing that I found has been very, very helpful to do in code. And in fact, that is one of the ways that we use the GitHub provider here at Pulumi. Is that we use it to manage our permissions to version control. Again, as I mentioned, you can create your application and infrastructure pipelines, both using infrastructure as code itself. You can manage your artifact management. So again, at Pulumi, for example, we have a JFrog provider for Artifactory, so you can manage all those package feeds. There may be other providers out there that will allow you to manage the permissions and actually the policies themselves. Your policies should be as code as well. Lo and behold, step 6 is actually doing that stuff. That policy as code. So you're already probably doing some sort of policy as code at present. If you're using AWS, for example, and you're writing IAM policies and managing them in code, that is policy as code in some level. But it's also important to talk about. There's sort of two general categories of controls. And so the last item on the pre-production side are preventative controls. And preventative controls are going to run before you provision some sort of application or infrastructure, right? Your preventative controls are going to be, for example, IAM policies are one. Pulumi's policy is code product. CrossGuard is another one. So that's going to run again. So, for example, CrossGuard, to take that example, that runs policies that you define again itself in code. It's going to run those against your infrastructure, and it's going to say, oh, you have an S3 bucket that is publicly readable. That is not in accordance with our organization's policy. So I will not allow you to provision that infrastructure in the first place. And the advantage of these preventative controls is that they provide fast feedback, right? So you will, in the case of Plumi policies code, you're going to run, like, for example, Plumi up or Plumi preview, which are, by the way, analogous to like Terraform apply or Terraform plan in the Terraform world. And so those preventive controls are going to look at your infrastructure as code and say, hey, is this compliant or not? If it's not compliant, it will prevent you from deploying, or at least give you feedback that you are not in compliance. You can actually set Pulumi policies themselves to be either advisory, which is kind of like a warning, or mandatory, which will be like an error, and it won't allow you to deploy it at all. Other examples of preventative controls, if you're in AWS, service control policies. You can use service control policies to, for example, say, okay, we are HIPAA compliant, and so we will, at our AWS organization level, which is like the top level of a group of AWS accounts. So organizations typically have one, or businesses, enterprises typically have one AWS organization, and then within that, you're going to have lots of different accounts and organizational units, et cetera, et cetera. So the way service control policies work is that you can say, hey, we are only allowed to use the HIPAA compliant services, and it will block non-HIPAA compliant services. And by the way, for the folks who are not in the United States, let me explain what HIPAA is. HIPAA is the US regulation around health data and it also typically involves our American health insurance industry. So it's a regulatory framework. I just picked it as an example because it's one that I'm somewhat familiar with. And then the other category are post-production detective controls. And detective controls are going to operate after something has been provisioned. So why would you not always want to use preventative controls? So you definitely want to lean towards preventative controls because they give quicker feedback. But detective controls, they have an advantage that they will catch everything, no matter which pathway it goes through. So detective controls are going to look at the infrastructure that is typically already deployed in the cloud or already deployed on your Kubernetes cluster. And it's going to say, hey, you've created an S3 bucket or changed the setting on an S3 bucket. If you did it, for example, through the console, that will be caught by a detective control, but it would not be caught by a preventative control, because preventative controls rely on you going through a certain pathway typically. So that's the difference between the two. But again, you want the emphasis to be more on preventative controls for early feedback, and then consider using detective controls as a longer term, as sort of like a backstop, a sort of second level of security and compliance. And that's it for the steps, right? Because we've now enabled all the parts of the platform. But I did want to talk a little bit about self-service infrastructure, right? So self-service is very commonly a part of platforms. It is typically an evolution that comes from IAC modules. So, as you are working as a platform team, of course, you're going to be working with infrastructure as code. That is pretty much a given for any platform engineering effort. You're probably going to have some sort of infrastructure. You're going to start to create these abstractions, right? Because you're going to start abstracting things. You're going to start discovering ways of standardizing, and you're going to have some sort of infrastructure as code modules that result from that. However, that may eventually evolve into some sort of So you might start using these IAC modules internally as a platform team. And then once you are confident enough in their stability and that their design is good, then you will make them publicly available for application teams to consume. They might consume them directly, or that might be via a sort of easier to use interface like a web UI or a command line tool. But self-service is definitely an evolution that comes from infrastructure as code modules typically. It's also important to understand that this does not have to be an all or nothing approach. I would absolutely recommend against a platform effort that starts immediately with self-service infrastructure. You need to kind of crawl, walk, run, I think is the way the nomenclature that's very popular in industry. So like, run is self-service infrastructure. And make sure that you know how to crawl or walk before you try to run when it comes to your platform engineering efforts. Also, I can speak to this directly from experience. It's going to be really, really hard to design a platform, especially with self-service infrastructure, if the software architecture is not itself that you're running is not foundationally sound. So what do I mean by that? Well, if you have a bunch of crazy fine-grained microservices that all need to be deployed together at the same time, that's bad design, and that is bad design. Let me be clear about that. That bad design is going to trickle down into your infrastructure and your platform as well. And you're going to have to start to do all these hacks that, like, for example, mean like, oh, we have to deploy every service in the system all at once. That is a pattern I have absolutely seen personally, directly in the field, and that resulted in a lot of really bad practices that made the platform essentially unmaintainable. I don't know what happened to that platform, but I know that it was clear to me and the other consultants who were working on that project that thing was going to have to be rewritten from scratch. So, you need to have some sort of sane foundational software architecture. And by the way, this basically comes in with like basic decent design of a distributed system. And that's a whole topic for another day, so I can't really get into that today. But you need to know that, like, software architecture has to be foundationally sound in order for the infrastructure and the platform to be successful. If you are doing self-service, you have to have clear documentation. This thing has to be intuitive. The self-service also has to extend to the help that your application teams might be seeking. Measurement is also important. So you're going to have measurable outcomes if you're going to move to self-service. And start small. Some great places to create a sort of service catalog style offering. Where someone's going to go in, they're going to click a few buttons, and they're going to have the infrastructure they need. Two great places to do that. One are CI/CD pipelines, which are a pain to set up, but also have a lot of repetitiveness to them. So, making CI/CD pipelines or self-service is really a great thing to do for your app teams. And the other thing is, like, consider how about databases, which are often operationally complex, but also have similar needs, right? You're going to need some sort of backup and recovery. You're going to need to use some sort of standardized engines. So consider looking at databases as a great way to start your self-service journey. So I'm going to take one little quick break to catch my breath. I don't see any questions in the questions tab, but if you have any, please chime in. I'll be happy to answer those as I go along. But what I want to move on to now are some common scenarios. These are problems that I've seen in the field, and I want to talk a little bit about what I feel the way to directionally solve these problems are. So the first issue that I like to talk about is when your platform is unloved, and there's kind of two ways that you would see this exhibited in the field. One is that teams are going around your platform, so they are somehow deploying their applications and infrastructure in ways that go around things that you have intentionally set up. The guardrails you've set up, they're going all the way around them to get to production. The second way that you might see this exhibited is that teams are using your platform and they're sticking to it, but they end up using a very inappropriate tool for the job. So, for example, if a team really needs a time series database, but they're using a relational database for that, that's going to be a disaster, right? So they're using the wrong tool for the job, or they really need maybe a serverless app, but they are deploying onto virtual machines because that's all you support. And a lot of times you're going to see, by the way, like the teams are creating infrastructure-ish things that they really shouldn't, that are actually already properly handled by your cloud provider, for example. So directionally, the way you want to fix this issue is you want to improve your customer focus, right? So one of the things you can do to get an idea of how far widespread the problem is start to use some of those detective controls I've talked about. So if there is a service or like let's say a database engine that you don't want your teams using, and they're going around the platform to use a detective control to find out how much raise an alert whenever a new if you've standardized on Postgres and a team is deploying using MySQL, use a detective control to say, hey, you spun up, for example, an RDS cluster that's using MySQL as its engine. But because you've already been kind of iced out as the platform team, you probably don't want to automatically shut it down, for example. From there, you want to find out how widespread the problem is, but then you need to start to talk to people, right? Because this is fundamentally, it is probably a people problem. Most of the problems that we deal with in IT are actually people problems, not technology problems. I'm sure you've heard that before. So, establish some personal relationships with the app teams. Say, hey, put a face to the platform team, that the application team knows, and be open to their feedback and open to their needs. Because a lot of times they might just be doing what they're being forced to do by someone higher up the chain. So, have empathy for what they are telling you, and try to adopt to their needs in the way the platform works. In very large organizations, by the way, the way to scale out this effort is to use satisfaction surveys. This is as far as I know, the most sort of scientifically sound way to determine how well your platform team is serving your application team's needs is via satisfaction surveys. So do leverage those. And there, of course, there are many, many tools out there, many of them free, that will allow you to do this. And if you are in a position to do so, allow outside contributions to the platform. For example, if you have an IAC module, allow pull requests to that module. But you also need to make sure you have a documented process for what is a way that will get that contribution actually a part of the platform. So in GitHub world, you might have a contributing.md that says, hey, if you're going to change something about our network module, please reach out to us first so we can make sure that it's in alignment with what we need to do, or to make sure that there is enough subject matter expertise involved in the process, for example. So application teams might want to change something about how your network module works, but you're going to need to have that reviewed by a networking expert before they either start work or before that contribution can be materialized and joined. See, we do have a question on the Q&A tab. Okay. Okay, so in my limited experience, I find that folks with an operations background tend to prefer IAC tools like Terraform rather than Pulumi, which is seen somewhat negatively as a tool pushed by folks with a development background. How do you propose IAC tools like Pulumi in such cases? That's a great question. So for those that don't know in the audience, the kind of the fundamental difference between Terraform and Pulumi is that so while both tools will allow you to manage resources and orchestrate their dependencies in multiple clouds within the same program, Pulumi's Terraform uses a domain-specific language called HashiCorp configuration language. It's basically like a nice form of JSON is probably the quickest way to put it if you're not familiar. Whereas Pulumi uses general purpose languages like TypeScript, Python, Go, C#, things like that. So that's the fundamental difference between those two tools. And yes, I mean, we've even seen that. I've seen that directly myself with conversations in the field where, they're like, well, Terraform looks like something I know. And so like, I don't want to learn a general purpose language like Pulumi. But I mean, at a certain scale, I think it is. I'd certainly feel comfortable saying that at a certain scale, Pulumi is going to be a much more productive tool. If you're defining 3 resources, no, it's not really going to make a difference between Pulumi and Terraform. But where Pulumi starts to shine and has and these general purpose language tools have an advantage, in my view, is when you start getting into more scale and you need to do something like use a for loop, or you need to use an external data source in order to drive the infrastructure you're creating. Like, for example, if you're keeping network ranges, like maybe you have, maybe your networking team is not super hip with infrastructure as code, and they keep an allow list of IP addresses in a Google Sheet somewhere, or they keep a list of reserved CIDR blocks or something like that. If they keep that information in a Google Sheet, using Pulumi, you can grab the Google Sheets SDK, pull that information down, and use that to drive your infrastructure. So the capabilities of a platform built with Pulumi are going to be much greater than one that uses Terraform. And that's no shade on Terraform, but because Pulumi uses general purpose languages, there's just so much you can do, so much more you can do in a general purpose language. So, for example, Pulumi also has this feature called Automation API, and this comes in directly to platform engineering efforts. Automation API makes it super easy. You can make command line programs that drive your infrastructure. So you can write a Pulumi program in Go, use Automation API, package that as a binary, give that out to your application teams, and use that to spin up a development environment, or use that so they can make a local environment that deploys all their builds. And you can do all that using like a single executable. And that's just not possible with Terraform. So, I mean, I would say that, if the use case is basic enough, there's not going to be that much difference. And if the resistance is that strong, okay. But if you're doing platform engineering at scale, the ability to use general purpose languages is just huge. And also, I think it's worth noting that most people in an operations background are going to know at least some Python. You would think that seems to be the most common language out there. So, try to talk to them and be like, hey, like, are you writing a script? You're writing scripts in Python? You can write Pulumi programs, and you're going to be able to do a lot more, again, because you have those general purpose language abilities. It's also going to make it easier to share code, right? You just publish a PyPI package if you want to share that code. So that's how I would answer that question. But back to the slides. So another problem I've seen very, very frequently in the field is you have IAC modules and they're a mess. And there's basically two ways that this kind of rears its ugly head. The first is that the modules are not stable, so you keep making modules and they're not stable, and you make breaking changes to them, and your customers, your application teams keep having to upgrade, and they're not happy about it. And so that's going to make them not like the platform team, or maybe even go around the platform. And the second is that internally you're finding that your IAC modules, they're taking way too much of your time to maintain. And I've seen both these patterns quite a bit. So you're doing a lot of churn in your modules, but you're not actually seeing a lot of benefit in terms of improved security, improved in terms of your application team's velocity, which of course you should be measuring. So you probably went too fast, too far. Don't feel bad. Getting IAC modules right is a really hard problem. It's even difficult, I would say, within Pulumi, it's hard. Like it's really hard to get an abstraction that works for everybody, or works for enough people, but still actually abstracts enough to be useful. So IAC modules are hard. It's actually easier to do within an organization where you have very clearly defined guidelines. But yeah, I mean, you've probably gone too far too fast. So try to be a little bit more conservative going forward in what you create. Be very, very careful before you put a publicly consumable module out there in the public. Try to keep your modules small. So I came up with this term, like, I don't even know if I came out with it, but there's a term that I'm familiar with. So that people talk about like level 1 constructs, which might be like, a raw subnet or something, and like level 2 constructs, which might be a VPC with like all the subnets defined or something like that. But you might do better to take some sort of middle ground between those two things. And so rather than creating some sort of component that has like 20 infrastructure resources, maybe make one that has like 3 to 5. Maybe you want to package up a Kubernetes resource with its corresponding IAM resource, right? If you're doing some sort of like bridging between those two things. Try to keep something small, focused, that does abstract something useful and takes like a very reasonable number of parameters. So you can see a couple of bullet points down. I have minimize, fan in, fan out. So that's what I'm talking about there. So fan in is the number of input parameters, fan out is the number of output parameters. And having a lot of both of those, certainly ones that are required, is generally speaking not a great thing, because it probably means that you are not necessarily abstracting enough from the user. So, and the other thing is, like, keep it experimental as long as you can, until you're confident that you have both the team skills and also enough understanding of the problem domain to maintain a stable interface. So there's two parts of maintaining a stable interface. One is that you have the design skills on your team to know how to allow a module to evolve without making a breaking change. And that's a design skill, and you kind of just learn that one by experience. Although there are, I'm sure there's resources out there, but it's more art than science, and it's something that you gain with experience. Which, by the way, is why most platform teams do not have junior level developers, and many of them don't even have mid-level developers. This is usually a mid-career or later type of role. And then the second part of keeping stable interfaces is that you need to know enough about what it is you're abstracting in order to maintain that stable interface. Because sometimes you might do everything right up front, but it's like, we thought that everything worked this way, but now we have to make a breaking change. And so you really want to minimize those breaking changes. Second is, look at your tooling. I have made the argument earlier in this presentation, and I would say so again, that having infrastructure as code in general purpose programming languages makes you more productive in the end. I think that's, I've been through both generations of tools, and I would always stick to general purpose languages. And again, I think Pulumi is the best tool in that space, because not only is it general purpose languages, but allows you to manage resources in any cloud. So with those two things together, I do think it's the best tool in the market. I'm not just saying that because I work here. I actually work here because I thought that, and that's why I applied for a job here. So that's tooling. When it comes to IAC, also, you need to have a clearly articulated support policy no matter what tool you're using. So how long are you going to support these things? How many past versions are you going to have? When is it mandatory for folks to upgrade? Sometimes upgrade paths might be long. Sometimes it might be short. Sometimes you might have some sort of new regulatory requirement, and it's like, no. Everybody needs to upgrade their auto scaling groups because we have this new, we have a new WAF that we're using in front of the load balancer that is part of our regulatory requirements or our new security policy. So some upgrades might be slow, some might be fast. They depend upon the needs of the business, but you should clearly articulate those things and make sure that everyone has that information. And then you can also use policy as code sometimes to get the desired results without modules. So for example, let's take the example of an S3 bucket, right? You might have an infrastructure as code module that creates an S3 bucket that is not publicly readable, and it has some sort of bucket policy attached to it. I'm picking S3 bucket as an example, but you can apply this to sort of any infrastructure. So that policy as code, you can enforce no public S3 buckets by giving a module out to everybody and reviewing all the code changes and making sure that everyone's using the module, right? That's one way to do it. But the other way is to use policy as code as a way to catch the behavior that you want to stop people doing. And so this fits in more into the ways that organizations use infrastructure as code modules as sort of as ways to actually enforce policy. But you can use policy as code, of course, also to enforce policy. So if you're having a really hard time getting a stable S3 bucket module, consider whether you might want to try to use policy as code more and leverage that to get your desired results without having a difficult or even impossible to maintain module. So that is how you work your way out of bad IAC modules. Another common scenario in production is the hot potato production incident. So for those that know, if you're not a native English speaker, when I say hot potato, it conjures up this visual of like you have a hot potato in your hands and you're throwing it to somebody else before your hand gets burnt. So everybody's kind of tossing it back and forth. It's like, I don't want this thing. And so what it looks like in practice, when you have a production incident, teams keep passing the responsibility back and forth for resolving an incident, or even worse, nobody responds to an incident because they don't think that they're responsible. So this is something that happens pretty commonly. The answer to this is that you need to be more intentional and you need to get better alignment. During the incident, you should start some sort of channel that could be a shared Google Doc, but it could be a Slack channel or whatever your company uses for chat. That's a great way to do this. And you should be logging what you're doing in that channel, even if it happens out of band. So, for example, I've been on incidents before where you need to get on the phone with someone. You need to write down that you are on the phone with so-and-so in the channel, and what you're discussing and what the action items that you're taking are. And the reason that you do that is that you use that log as your primary guide to what's called a blameless postmortem. And blameless postmortems are a practice in operations where you look at what the incident was, what was the root cause, what were the actions we took to diagnose this, and then you figure out essentially how can we do better next time? What are the actions we're going to take to do better next time? You need to make sure that you have it clearly articulated who's responsible for what, and that's clearly written down. So if you remember earlier, I gave you this example of this this team thing, and if you look, there's systems we support, and then there's also a what support we provide and when. And so you need to ensure that all the teams involved in whatever the production incident was, all have this defined somewhere, and ideally in the same sort of system where everybody can find it. So when the issue arises, it is easy for everyone to find out, okay, this is a database issue. I need to go to the database team to get them to resolve this. Or I can't deploy to production. I need to page the platform team if your platform team offers after hours support. And again, those things should be clearly articulated and in a public place where everybody can find them. And I lost my place. Here we go. Oh, whoop. Nope. Okay. Sorry. Now we're back. Okay. So, make sure you know who's responsible for what, write it down, share it, make it public. Make sure that your alerts, make sure that you have a good signal to noise ratio in your alerting system. If you are firing off a bunch of alerts to your operations team, and most of the time they require no action, it's going to be really, really hard for that operations person to know what's important and what's not. And if you keep alerting them and they keep responding, then you're going to burn them out if these aren't actual important things. If you keep alerting them and it is important, you're going to burn them out because they're constantly, when they're on call, is going to be miserable. And then the other thing is that you need to have sustainable on-call rotation. So, for example, it's typically going to be 2 people on call at once, a primary and a secondary, and then those rotations are going to be maybe for 2 weeks, and you're going to have 6 total people. So you can't have the same people on call all the time. It's just not sustainable. It's going to make you miserable. Okay, so let's hop over to to questions real quick. I'm going to throw this up. What is the best momentum to adopt platform engineering? I mean, no doubt it's a good approach for most teams. But what do we need to change first? Should we first have a good maturity already in place? All apps running with CI/CD, golden pipelines, etc. So the golden pipelines themselves can be a part of that platform team. But again, I would say that the first place you're going to start again are those pre-production services. Those are the things I would make sure you get under control first. And then if there's cloud infrastructure involved, then you bring in infrastructure as code next. But you don't have to be at maximum maturity. The thing that you need to be careful about when it comes to moving too fast is kind of locking yourselves into either IAC modules or self-service infrastructure. And this is kind of what harkens back to what I talked about before your organization is actually ready to do so. So don't abstract too much upfront. Take a very basic quick wins approach to start. Okay, let's start talking to the application teams. What are their biggest problems? what is easy for us to deliver in a way that we feel confident about, and kind of start there. And also, what is going to make the biggest impact on these sort of measurable outcomes of application team velocity, or in terms of operational excellence? Pick one of those things, one of those major metrics that I mentioned before. Okay, so and now the final scenario, and then we'll be doing some more Q&A, and then we will get out of here. So the final scenario is the platform is a total mess. We have a phrase in English that is too clever by half. So what that means is that you did something that was like really intricate or fancy or smart, but it didn't actually produce the desired results. To use Dungeons and Dragons terminology, it's like someone who has a very high wisdom, or excuse me, very high intelligence score, which means that like, oh, you're like able to think through things and you have like a lot of good ideas, but very low wisdom, which means that when they're actually applied, they don't actually produce results. So it's kind of like having a lot of power in sports, but not a lot of control. So like to use a baseball analogy, and unfortunately, I know that a lot of you are not from the baseball world. It's like being able to throw the ball really, really fast, but not having control. So you might hit the batter, which is bad if you're a pitcher. Um, so we've done something. It's really quote unquote smart. It's very fancy. But now our metrics are getting worse by the day. And every day that goes along, we're moving slower and slower, or we're having more production incidents, et cetera, et cetera. And some examples of how I've seen this in the field. People will make their own IAC module systems. Please, please, please do not do that. The one exception to that kind of is like Pulumi, is like Pulumi's automation API, which kind of makes it easier to not necessarily make your own module system, but to kind of present an abstraction layer on top of infrastructure as code. So, if, for example, you're using automation API and you want to pull your configuration from a YAML file and distribute it as an executable, you can do that, right? And Pulumi is kind of the only tool that will allow you to do that. But in most cases, you do not want to do any sort of bespoke abstraction on top of IAC. I've seen organizations that create their own templating system that generates infrastructure as code. I would also urge you not to do that in Pulumi or any other tool. So, if you want to use CDK, for example, which generates CloudFormation, that's fine, right? That is a tool that AWS maintains with their untold billions and billions of dollars and their staff of however many are on the CDK team. And they have tons of resources to maintain that. Your organization almost certainly does not have the resources to maintain it, and so you shouldn't do it. I've worked for a company that forked a scheduler, kind of like a predecessor to Kubernetes. They forked that because they thought it would give them competitive advantage. That product, the original product, is stopped being maintained, and I do not know whether they have yet migrated off of their own fork. So they got stuck maintaining that, for quite a while. That same company also had unit tests run on a bespoke distributed test runner. So you get the general theme here, right? These are not related to what your business is trying to do, right? You do not, unless you work for a company that makes bespoke distributed test runners, your platform team should not be making one. And if you do, you're probably going to regret it, and it's going to be very, very expensive to fix. So the solution here, well, it's bad news. These are all very, very expensive mistakes that are going to take a long time to unwind. But they ultimately do need to be unwound in the long term. So you should have a long-term plan to undo these really bad mistakes. And most of these mistakes, by the way, come from copying things that big tech does. But there's key differences between big tech and the organization that you work in. So for starters, big tech is probably bigger than your organization. And they also they probably have much more scale. And then they also have more technical expertise than your organization does. Even if you work for a really, really well-run enterprise that has like a good IT org, you're still not at Google scale. So don't necessarily adopt what Google does or what Netflix does and think that it's going to work for your organization. They have different needs than your typical enterprise does. So unless you really are a big tech, and some of you are, and so if that's the case, then ignore my advice here. But if you're not big tech, stick to the formula, that stick to the things that your business is actually there for. So don't go doing this sort of resume driven development, because it can be a long-term disaster for your platform efforts, and it's going to be very, very hard to undo. So there's no easy fix here. Again, you're going to try to look for some quick wins. Is there ways that we can make this a little bit more efficient? But in the long term, you're going to have to undo these issues. And again, the most important thing is kind of the bottom bullet point here, that you need to refocus, right? What do the things that your platform team does, what it actually brings competitive advantage? And what your organization does that brings competitive advantage is typically what your application teams are doing. And what your platform team's role is primarily to support those application teams in what they need. All right, so I have time for a few more questions, and then we're going to wrap up. So I have a question here. Let's take a look. My cloud infrastructure is already heavily supported by CI/CD processes, but nothing is reflected in state files like those in Pulumi. What strategy do you recommend to reflect the current infrastructure in IAC? So what I'm going to guess this person is asking, if nothing is reflected in state files, then you're probably I'm going to use the Amazon world. So apologies if you're not using Amazon tooling. So you can do infrastructure as code using purely declarative things. So that would be in the Amazon world, that would be like Bot 03, or like the Google Cloud SDK or the Azure SDK, right? So if you are, so you can, these tools, for example, if you want to create a VPC, you can create a VPC, right? But the key difference between tools that like this type of infrastructure as code and declarative infrastructure as code is that all declarative infrastructure as code tools use what is called a state file. And the state file keeps track of what infrastructure you already have, and it compares it to what you've declared that you want in, for example, your Pulumi program. And it does a diff between these two things, and it will figure out what needs to be done in what order. So that, like, if we take the example of VPC, if you're just scripting infrastructure, you're going to have to say create this unless it's already been created. If you're doing declarative infrastructure as code, which is a much, much better approach, and Pulumi, by the way, is a declarative tool, then you only need to say what the desired end state is. So I want a network with these subnets, and I want these virtual machines, and the tool will figure out the steps needed to get there. So I think that if you're not using a declarative infrastructure as code tool, all of which, to my knowledge, require state files, then you should move to them as quickly as possible. In Pulumi world, you would do this by importing your infrastructure into Pulumi, and Diana will be able to get you a link to describe that. So I don't see any more questions, and it is getting toward the end of our time together. So let's wrap it up. Here's the thing to take away, right? When in doubt, I think it's really, really useful to have what we call in English a North Star. So this is kind of like your the thing that you kind of always come back to, your sort of first principles, and that your job as a platform team is to help deliver software. And so specifically, you need to help your application teams deliver more quickly in ways that enable operational excellence, so that the application doesn't go down, or if it does go down, you're able to respond to it quickly. And it needs to be in accordance with your security and compliance requirements. So whatever your org security policies are, you need to make sure that those applications, when they're running, are in accordance with that. And that is so the organization can accomplish its goals. If you're in a for-profit industry, then it is, let's say, to make money ultimately, right? You're going to deliver or to grow the business, one of those two things. If you are in, for example, government services, it's to serve your citizens better. But whatever the organization is, you're there to help them deliver software in these ways so that they can accomplish their goals. If you liked what you heard today, I really appreciate you spending time with us. You can come and join us for an upcoming workshop. So Next week, we'll be presenting Getting Started on Kubernetes with AWS with Pulumi. So it's going to be a very different talk than this. It's going to be much more in the code and specific stuff and demos and things like that. And then there's also going to be something that's kind of a mix between this type of talk and showing like code on the screen. And that's going to be securing pipelines in regulated industries, and that's coming up later this month. You can join us for our upcoming workshops. They're all on the Pulumi website. And with that, I would like to thank you all for taking this time to spend with us. I hope you found this content valuable. I really, really appreciate you joining us, and we hope that we will see you again soon. So long, everybody. Be well, and we'll hopefully see you again soon. Bye-bye.